Ladies and gentlemen, I'd like to welcome you back to the second part of our conference program, Fire and Rescue Tactical Initiatives with a focus on hydrocarbon fires. We are now proceeding, and I'd like to introduce you to the chairman of the second session, Mr. Mohaned Awad, who is the Regional Director of Business Development for the Bristol Concord Cordex Group. Mohaned is a chemical engineer with 2 bachelor degrees in chemical engineering science and environmental science from the University of Western Ontario, Canada. Mohaned also serves as a member of the board of directors of GHSEF, the Joint Oil Industry Fire Forum. GHSEF is a not-for-profit organization dedicated to developing competence of emerging services and management in high hazard industries. I would now like to welcome Mohaned Awad and ask Mohaned to come on stage. Thanks, Mohaned.
Thank you so much, Philip. First of all, I would like to thank you for organizing this forum. I was riveted, frankly, in the first session by all the speakers, and I know there was a lot of conversations also behind the scene and how we enjoyed this forum, especially that this is one of the first forums to come to the region. So thanking Richard, Irie, and Niels, that was a great first session. And I think our target with the second session, with great guests from ADNOC, engineer Mariusz, and also Aramco engineer Menhal, is to try to provide some local perspectives or local content into the science that we are talking about, and that is the fire and rescue tactical review of these hydrocarbon fires. Assalamu alaikum. I would also like to take some questions in Arabic. فإذا أي حد حابب يحكي معي أو يبعث رسائل باللغة العربية، أنا هكون مستعد أحكي كمان باللغة العربية وأترجم أي من الأسئلة اللي أنتم عندكم إياها إلى اللغة الإنجليزية حتى نقدر نرجع إليكم بالأسئلة اللي بدكم إياها. So I'd like to introduce my first speaker, Engineer Mariusz. Please, if you can take the form. Thank you.
Yes. Right. So I'll just share my screen. Just let me know if it's successful. Is it?
It's perfect. Go ahead.
All right. Okay. So good afternoon. Thank you very much to the organizers for this opportunity. And let me shortly introduce myself. My name is Mariusz Wojciech Mikolajczyk. My fire service career started in 1991 in the National Fire Service of Poland, where I served in various officers' positions. In 2005, I joined Abu Dhabi National Oil Company, working in Ruwais industrial area as a senior fire officer. And from 2018, I'm appointed in the ADNOC headquarters as a fire and rescue specialist, focusing on the corporate governance for emergency response across ADNOC Group companies. Today, I will talk about the comprehensive emergency response planning for hydrocarbon atmospheric storage tank fires. We will go through the key elements that should be taken into account by any emergency response organization when planning a response for full surface fires of hydrocarbon storage tanks, which are the most demanding emergency scenarios in oil and gas industry in terms of the resource requirements. Information for this presentation has been collected through various reports and presentations, fire literature, and through my personal communications and experience, including ADNOC Group. Although the large-scale tank fires are very rare, they present a huge challenge to firefighters. They pose a difficult budgetary decision to facility owners and operators because of its catastrophic potential in the case of the escalation that can result in the total loss of a facility, business interruption, and environmental impact. What are the challenges of the emergency response planning process? We should say clearly that there is no easy way to collect the detailed enough information about the full surface fires of the hydrocarbon storage tanks. Today we have this opportunity. In different fire publications, we can find info about 500 tank fires, and only for 5% detailed information have been provided. In only very few cases, comprehensive reports are available, providing a full data about such fire incidents. Also, based on the results from the literature review, it is obvious that there is a very limited documented experience from large-scale fire tests. So let us start from the elements of emergency response preparedness. Choosing response strategy. It is not so obvious, to be honest. If we decide to fight the fire, then we should select foam concentrate. Then calculate firefighting media, ensuring that they are sufficient, determine equipment and staffing required for the intervention, then develop pre-incident plan, and then test it in the full-scale exercise. Before decision is taken regarding the response strategy, it is necessary to define and understand the risk that may be present by such fire event. Then the stakeholders, knowing the risk, they can choose how to handle it. Decision can be taken on the three available strategies. Passive, where there is no firefighting activities. The stored fuel tank is allowed to burn out without any intervention. Defensive, no firefighting activities aiming at the burning tank. The response concentrating only on the cooling surrounding exposures in order to prevent escalation. And the same in the previous strategy, allowing the involved tank fuel to burn out. In both mentioned strategies, the burnout process will result in a fire that is likely to last several days, complete loss of the stored product, environmental reputation problems, and in some cases, potential for boil over. Therefore, the passive and defensive strategies are often not acceptable options for large atmospheric storage tank fires. The third option is called offensive. It is an attempt to extinguish the fire using a fixed, semi-fixed, mobile, or combination of these fire protection systems. The mobile application is always provided over the top of the tank using a large capacity monitors, if we talk about the large tanks. Extinguishment of the tank fires can only be obtained by using firefighting foam. However, historically, the chances of successful fire control and extinguishment are relatively low, especially for larger diameter tanks. The largest hydrocarbon tank fire successfully extinguished had a diameter of 82.4 meters. Also, we should keep in mind that the most effective foam today containing fluorosurfactants are under debate due to environmental concerns. Most probably, they will be excluded from the use in the predictable future. So what determining the strategy? Definitely effects of destructive consequences of the scenario. Associated risk like a boil-over phenomenon. Environment impact, including the consequences of firefighting activities. Potential reputation impact, business continuity aspect, realistic assessment of actual existing firefighting capabilities, and associated costs like CapEx and OpEx. Assuming that third option has been selected, we are going to fight the fire, then we have to choose a foam concentrate grade. There is a wide range of foam concentrate grades. Few examples: aqueous film-forming foam, film-forming fluoroprotein, and a version suitable for polyliquids, fluoroprotein or fluorine-free foam, our rising star. The ADNOC preferred foam concentrate grade is AFFF 13% due to its unique and high performance parameters that maximize probability of successful intervention. And here, I would like to emphasize that we aim to collect properly and properly dispose all foam solution runoff in case of an intervention. One of the main factors in achieving an efficient extinguishment is the use of high quality foam. So what parameters should we consider? Viscosity, that determines the liquid movement conditions. Mixing ratio determines the amount of foam concentrate needed for firefighting. pH value for corrosivity reflection, suitability with the fresh and seawater, and there might be a significant difference in the foam performance when using sea and fresh water. Storage temperature and shelf life, spreading coefficient tell us about the ability of the foam to spread across fuel surface. Expansion ratio and draining rate, foam concentrate stability, maximum sediment percentage, extinguishing performance class. This parameter tell us about the ability of the finished foam to knock out the flames. Burn back resistance level, that's ability of the finished foam to resist the heat radiation. The last two factors determining the minimum requirement application rate. Choosing low performance foam, we decrease probability of putting out a fire, and at the same time we increase the logistics and operational requirements for the intervention. Simply saying, we will need more foam. On the right side, we can see a table that shows a generic dependencies between foam grade and foam performance. However, the exact foam performance class and burn back resistance shall be determined by the relevant tests. Next step is to select the standard for foam concentrate grade and finish foam testing to confirm the required parameters in view of the specification provided by foam manufacturer. And there is a number of standards that might be taken for the account, like EN, NFPA, UL, FM. Last fire, the ADNOC preferred standards is EN 1568 due to the wide range specified requirements for the concentrate, foam concentrate and finish foam. In addition, we require a last fire test with a certain performance level. The last step in this stage is to determine lab competencies attestation requirements to ensure that the provided foam test results are fully reliable. ADNOC choice is ISO 17025. The standards specify requirements for the testing and calibration laboratories, their competence, impartiality, and consistent operations. In addition, it is necessary to ensure that the lab scope of certification includes the chosen foam standard that we wish to use for testing of our foam. We need to test the foam at least annually to confirm its original parameters. To determine the foam solution needs, we use EN 13565 Part 2. This standard provides factors that link the foam application needs with the tank size and the foam performance. An application rate equation we can see on the right side. It is simple multiplication of nominal application rate and the factor values. Here, basically, we have to determine the required amounts of flows of foam solution for firefighting and water cooling. For cooling needs, the radiant heat models are often used to determine firewater demands that shall be utilized for exposure protection of adjacent tanks and structures. Table at the bottom show example of foam solution calculations for atmospheric storage tank in diameter of 110 meters. Two rows shows the difference in calculation outcomes respectively for foam concentrate mixing 1 and 3%. I would like to draw your attention especially on the figures related to the required foam flow and amount. The flow difference is 2.3 cubic meters per minute, and amount is over 300 cubic meters. It is a huge difference in both cases that impacting the emergency sustain logistics. Therefore, the mixing ratio shall be taken to the account when choosing the foam concentrate. It cannot be ignored. Also, we should keep in mind that the fire models are empirical based on data from small-scale laboratory experiments, and remaining uncertainty in the models is how to scale this data when increasing the length scale by orders of magnitude from tank diameter 10 to 100 meters or bigger. More work is needed to improve the accuracy of the data for large tanks and for various types of foam in terms of application rate, distance that foam can effectively travel across burning liquid surface. Today's manufacturers are saying between 30 and 50 meters. That's a traveling distance. To avoid reignition of the extinguished tank, the post-fire foam application shall be guaranteed to maintain the sufficient foam blanket on the fuel surface until the remaining product is removed. In this table, for sake of this calculation, was considered 50% more foam than it is required for extinguishing the fire. Right, having both water and foam solution flow demands, we can determine the equipment needs. So foam proportioning system, foam and water monitors, foam concentrate carriers, firewater supply equipment, infrastructure. We have to identify the sufficient water source, pumps, hoses. It is necessary to ensure that firewater system capabilities are sufficient for uninterrupted water supply during the entire emergency. We should remember that practical experience from fires exemplifies the importance of using large-scale equipment. And I know that there might be some controversy here. And the need for an increased application rate when we fighting large diameter tank fires. Knowing what equipment we need to use for a given scenario, we can determine staffing by breaking down the emergency response strategy into manageable, feasible, tactical tasks to be carried out by the operating units. Basically, we must find answers for a question: what number of staff is required to provide timely deployment of the required equipment and safely operated during the entire emergency response process. It's also important to determine the staff competency requirements. practice shows that the full surface tank fires might require in excess of 100 responders, what was mentioned the previous session. Not all of them need to be carrier firefighters, but it requires to select tasks that can be carried out by auxiliary responders. Full surface fires on a large diameter tanks pose an extraordinary logistic and coordination challenges. And as I have mentioned earlier, there is limited evidence about the fires that have been successfully extinguished. This is why we shall prepare a detailed pre-incident plan to increase probability of successful intervention. Talking about solving the logistic challenges, we should pay attention to the needs of using a large capacity monitors, large diameter hoses, and large capacity foam concentrate carriers. Let us just remind ourselves the table which was presented a minute ago, and the amount of foam which is required to fight such big tanks. If we use equipment, large capacity equipment, then the logistic become manageable. The foam solution supply in terms of pressure, flow rate, and adequate amount are the most important factors in launching a successful extinguishing operation, unless, excuse me, an adequate and uninterrupted foam solution supply is not guaranteed, the extinguishing attempt should not start. Of course, the longer a tank is allowed to burn, the greater danger of escalation and more difficult to put it out. Therefore, the foam attack should be launched as quickly as possible, but the foam application rate and duration shall not be compromised. It is good practice to test PIP elements before conducting a full-scale exercise to maximize its effectiveness. Now, this includes both tabletop and practical exercises. We have to ensure that emergency responders are capable to implement our pre-incident plan. It must be a feasible goal for them, and the feasibility shall be confirmed in the full-scale exercises. The PIP shall be reviewed periodically and updated whenever any of its elements has been changed. So, till now, we have chosen the strategy, find the fire, foam concentrate grades, calculations are done, we have determined the staff and equipment needed, and we have our pre-incident plan on paper. So it is time for the last point in this journey, the PIP practical verification. We need to assess all elements of the PIP that were elaborated until now work only on the paper. As dispatching process, command and control, radio communication arrangement, logistic solutions, correctness of equipment positioning, staffing adequacy, safety plan for emergency response, medical support, and provision of rehabilitation for the responders, because it will be not a quick intervention. This we can assume. It is crucial to carefully select observers and evaluators, ensuring their substantial contribution to the exercise assessment process. We have to be open for constructive criticism, challenging the PIP status quo. So, who's supposed to be involved in the full-scale scenarios? A controller to be manage and direct the overall of the exercise. Players means responders, as in the real emergency and the planned operation personnel. Simulators who will drive the injection messages to the players. Then observers to document the exercise plan, and evaluators who will assess performance. I would not recommend to mix those rules in case of full surveys, full scale exercises. Also, it is important for the process transparency to select an appropriate evaluation method to determine whether the exercise objectives were achieved. As output of the exercise, a clear PIP improvement plan shall be produced and then consequently implemented. Thank you very much. That's all from my side.
Thank you so much, Mariusz. That was excellent and very informative. I certainly picked up a few things there. I will open the floor now to any questions. We are watching and monitoring the forum. So if anybody has any questions, please feel free to send them down and I will read them out to Engineer Mariusz. Very quickly off the bat, Mariusz, one of the questions that I wanted to ask you was, considering that this part of the world contains probably some of the largest oil and gas process systems and bunkering facilities, what other considerations do you think we would take into account just because of the local conditions here, or what would be done differently, let's say at your PIP level or incident planning level, that you would do differently, or even foam selection than say our European counterparts? Or do you think the tactics would be very similar?
Yeah, that's a good question, Actually, I don't think so that a big difference between the fire risk associated with the petrochemical business. If you just compare a presentation of Ari's and mine, you can see, and we didn't agree that the main points, right? We didn't talk about it earlier. You can see that the approach is very similar. We just have the same challenges. What will be the difference? Definitely the climate is different, right? That's UAE have a different climate, and that's related with that challenges. The foam concentrate are tested at usually or certified at 20 degrees Celsius. Here we got a slightly different temperatures, particularly during summertime. But I will not see, I don't see a big differences in the approach for the Europe or different corners of the world comparing UAE.
Well, let me ask you then another question just about, let's say, what else the region would benefit from. Do you think more research, indigenous research, let's say with regards to temperature, foam storage? Because I know there's not a lot of data out there regarding the type of conditions that we have, especially I know in Kuwait, daytime temperatures during the summer can go up to 50 plus. In the UAE and some of the Western regions as well, they can go higher. What do you feel the market can respond to with regards to either more indigenous research or foam testing? And are these type of facilities or let's say research available to you locally?
See, definitely. Absolutely, yes. We have to just engage a scientist and local intellectual potential to support, to enhance fire protection. The tanks are getting bigger, right? And the technology is, it's tough to, we don't have a ready solutions, for this growing size of the tanks. Foam concentrates. Now we are just in the front of the new challenges, environmental challenges posed by the fluorine surfactants. It needs much more research work than it's done up to now. Companies like ADNOC definitely is focusing on the environment. There's no doubt about it. and all those companies are. But we have to just get as well some solution which is proved that does work. So that's a wide field for local research to support fire protection. Engineering solutions, you know, one thing is just to improve a way of fighting the fire, so improve foam, firefighting foam, but another is just to minimize the risk of ignition, of starting the fire, and that's engineering science have to be employed, right?
Through that. Well, you brought up the question, and not myself. I was going to ask you about the foam and ADNOC's philosophy towards transitioning from C8 to C6 foam. And now, is there any plans in the future to look at fluorine-free as an alternative as well? Or is that still far off?
No, definitely. We are deeply monitoring, closely monitoring the market. We are member of Last Fire. So Last Fire is not only discussing the fluorine-free foams, but as well undertaking some tests. And yes, we are looking future, you know, to adopt F3 foams. But I think that, you know, this type of foams needs to be mature on the market. There's still not enough information, you know. And of course, I think it will happen the same as with Hylons 20 years ago. It was just disappeared one day. But to be prepared for that, we have been starting working since now, and we do that. However, as you might know, that there is no a good alternative today for the AFFF foams. As I said, F3 foams needs more. That's my point of view. Needs a bit more testing and improvements. They work with the narrow segment of liquids, but you know, and this, you know, this is another link to the local research centers. When I think that a close future will push us to customize, to prepare a customized foam concentrate for our needs.
I would agree with you very much there, Mariusz. I think fluorine-free is the future. However, there's still a lot of research that needs to be done on both the application rate side, appliance side, without a doubt. I've got a question coming in from Mr. Terry Johnson. I'll just read it as is. Clearly, with any incident involving hydrocarbons and particularly stored petrochemicals, there are two distinct phases, unfortunately, usually all labeled as emergency response protocols, which quite obviously this is not the case in modern scenarios. Phase one is surely better titled as emergency response and resilience with, and then gets cut off. I think he had a technical issue there. But I think what Mr. Terry was trying to say is, in terms of specifically your PIPs or your emergency response protocols, again, you know, separating preparation and actual, you know, testing or verifying your PIPs. What are the challenges are you facing with those as well, Engineer Mariusz? If you could elaborate more on that.
Okay. You know, actually, the preparation has a sense if all elements are okay, if all elements are elaborated and ensure it will work during emergency. So in my opinion, you know, because that's a lot of parties are involved in preparation as well, as it was mentioned earlier, that we have to just ensure that organization is capable to do that. Then the equipment is there, then the firefighting media are there, and then everything have to just work together in this first, let me say, 1 hour to set it up as it should be. Otherwise, the probability of successful intervention is going down. So this is the challenge, you know. We don't have so many events, or we don't have many events, thanks for God, like full surface fires or big tanks. So it is a challenge to verify it in practice. It's cost money, it's cost certain efforts, and it is not easy to properly assess. It's why I just mentioned in my presentation that it is very important to get right people which will observe and evaluate the process.
Well, let's thank you so much, Engineer Mariusz. I really enjoyed that, and I'm sure our listeners did as well. Just for the sake of keeping time, with your permission, I'd like to move to the next presenter right now. Engineer Mohaned, are you there?
Thank you very much.
You're very welcome, sir. Thank you.